Hello, welcome to SMP call. Today we are going to solve the day 7 of August LeetCode challenge. So today's problem is vertical order traversal of a binary tree. Okay, so basically if you read the problem statement, it's saying that you will be given one tree, basically one root node, and you need to traverse the tree in vertical order, right? And you need to then return the output. So let's see the example. Let's see two examples first. At first we will see one smaller example, then we will see one larger example with much more number of tree nodes. Okay, then we will try to solve it. Okay, so basically what is vertical order traversal? So if you see the smaller tree, so what is vertical order? We will traverse the tree in vertical order only, right? So at first we will traverse the leftmost node, then we will traverse the 3 and 15, then we will traverse 20, then we will traverse 7, right? Then we are going to return it like this, right? It should be 3, then again it should be 9, since it's the leftmost one, then it should be 3 and 15, then it should be 20, then it should be 7, right? We need to traverse in this order. But if you read the problem statement, you said that we can think that for each and every node we have one position associated, right? X and Y. So what is that? So basically it is like that. You can think that we can see the X and Y coordinate, right? So basically at first our root is at 0, 0 location. So in this case 3 is our root, right? So we can consider 0 and 0 for root node, right? 3, right? Now for 9, what will be the xy value? Since we are moving to the left side, right? So it should be x minus 1, right? So it should be minus 1, and we are coming to the downward, so y will be increased, right? It should be minus 1 and 1. What will happen for 2? For 2 again, it will be x plus 1, right? So it should be 1 again, and y is also 1, right? For 15, it will be again, we are moving to the left side, so 1 minus 1 is 0, and y should be 2. Again for 7, what will happen? For 7 also, it should be, we are moving to the right side, so 1 plus 1, 2, and again y will be 2, right? So whenever we will be done with our pointing, then we can easily identify, right? So we will start from the leftmost or minimum one, right? So minus 1 is minimum. So we are going to add that in our list first, in the result, right? Result list, right? So at first 9, then for 0, we have two options, right? 3 and 15. Since we are doing vertical, so we will start from the top one, right? Top to bottom. So we will consider the top tree node first, right? After that we will consider 15. Now I will move to the right side and I will consider 20, then I will move to the right again and I will consider 7, right? And then we are going to return 9, 3, 15, 27. Okay, so what will happen for the, now let's see for the larger example with much more number of nodes, right? So again we are going to do the same thing. Okay, so let's see the larger example. So what will happen for this one, right? So again we will start from 0, 0, right? So our 1 is our root node, it should be 0 and 0, right? Now what will happen for 2, right? So we are moving to the left side, so it should be minus 1 and it should be y value should be 1, right? Now what will happen for 4? So again we are moving to the leftward direction, right? So it should be minus 1 and plus minus 1, right? So it will be minus 2 and y will be 2 only, right? So what will happen for 4 now? Let's see. So for 4 again we are moving to the right side, so minus 1 plus 1, it should be 0, and again I'm increasing my y, right? So it should be 0, 2. So now let's come to the 3. So for 3 again we are moving to the right direction, so it will be 0 plus 1, and again my y will be 1, right? And for 6 it will be, for 6 since we are moving to the again left, so 1 minus 1 is 0, and y should be 2, right? And again for 7 it should be 2 and 2, right? So basically after pointing x and y it will look like this. So now very easily we can move forward, right? Or we can do the vertical order traversal, right? So basically we will start from minus 2, since that's the minimum one, then we will cover the minus 1. Now in this case you can see that for 0 node we have 3 options, right? 1, 5 and 6. We will cover these 3, and again after that we can cover 3, then we can cover 7, right? But the interesting thing is, whenever you will find this kind of scenario, right? So for 0, so x is similar for these 3, right? But since we are following top to bottom approach, we will consider the top one first, right? So we will consider 1 first, and but if you compare the 5 and 6, right? In this case, our x value is same for both 5 and 6, right? 0, x is 0, and y is also 0, right? Y is also 2, right? So y is also same. So in this case, whenever your x and y are equal, then we need to consider the smaller number 1 first, right? So in this case, out of 5 and 6, 5 is the smaller one, right? So our sequence will be like this: 1, 5 and 6, okay? And rest will remain same. At first we will consider 4, then 2, then 1, 5, 6, then 3 and 7, right? So this is the problem statement. So let's try to solve it, right? So if you understand this problem properly, then you can surely understand that somehow we need to maintain these points, right? X and y. Using that we can sort. So basically we are going to create one POJO. You can name it as points or something like this. and in that we are going to maintain three things: x value, y value, and our current value, right, of the node 1. That one we need to store in our list, right, whatever we are going to return. So basically we will going to take one POJO or create one POJO in Java. In that POJO we are going to track these three value. Now what we can do, so since it's a tree, right, so we have two options: either we can do BFS or we can do DFS. So in this scenario probably we can do the DFS one, right, depth first search. What I will do, I will take one temporary array. So let me take one array, okay, quickly. So I will going to take, sorry, so just a second. So we are going to take one temporary array probably. So and what we will do, I am going to traverse it, right. So I am going to do the depth for traversal. So I can go to 1, then again I will come to 2, then again 4, like this, right. So we are going to do depth for traversal. Basically we are going to the each node and we are going to create one pointer, right. So whatever class we are going to create one pointer class using those x, y and value, right, node value, right. So again 5, then again we can go to 3, let me add 2 more column there. So it should be like this, okay, just another one, okay. So it should be go 3, then again 6, then again 7, right. So basically we will run DFS and we will traverse all the nodes, right. So we should not bother about the vertical order right now, right. So we are just traversing all the nodes using DFS, right, and we are going to store that in a list or array list or in list, right. Now since we are creating our custom class, so pointer class or point class, and we are going to implement the sorting logic there, right. So we basically have three conditions. One condition is x not equal to x, another condition is x equal to x but y is not equal to y, and we have another condition whenever x is also not equal, x is also equal and y is also equal. In that case we are going to consider the value, right, actual value. So we need to perform sorting based on these three conditions, right. So we can use comparable for the same and we can sort this thing, right. So what we will do, we will traverse this using DFS. So it will look something like this. Then we will going to sort that according to our sorting logic, right, these three logic. Then we can directly identify, right. So whatever is 0, 0 and so we will pick one by one. So we will pick the lowest one first, -2, and we can move further out, right. So let's write code, Java code for the same, and we will get better understanding. And after that I am going to give you the code walkthrough also, right. So let's write the Java code first. Okay, so let's write it. So let me reset quickly. So as I told you, what we will do, we are going to create one POJO, extra POJO class, right. So let us create that. It should be class, and it should be let me name it as pointer, something like this, okay. And we are going to use the inbuilt comparable. So implements, it should be implements comparable, okay, and its type should be pointer only, okay. Now what we will do, we are just going to define three properties here. One should be the x, one should be y, and one should be the value, right, the value. Or let me name it as value only, okay. Now we are going to create one default constructor to setting up those value. So it should be int x and it should be int y, then again it should be int value. Now what I will do, we are just assign this value, right, this dot x equals to x. Now what I will do, this dot y equals to y, then again this dot value equals to value, okay. So let us do this quickly. Now what I will do, so now we need to write the sorting logic, right. So let's write the sorting logic now, okay. So it should be public, and we are going to return integer value from here, and we are going to just override the inbuilt compare to method, right, and we are going to pass the pointer here, pointer, and it should be next, something like this, okay. And we are overriding this, so let us annotate as override only. Now let's write our custom sort logic here. So what will happen here, so if this dot x not equals to next dot x, right, so that means my x are not equal, right. In this case we are going to return the smaller x, right. So this dot x minus next dot x. Okay, so we are going to return like this. Now what will happen, let's suppose my x is equal, right? Now I am going to check for y, right? So else if this dot y not equals to next dot y. So in this case we are considering that my x is equal but my y is not equal, right? So what we will do, we are going to return this dot y minus next dot y, right? So whichever is smaller, we are going to return that, right? Now suppose both the scenarios are not matching, right? So my x and y both are equal, right? In that case we are going to consider the value only, right? So this dot value minus next dot value. Okay, so it should be minus. Let me write that quickly. Yeah, I think that's pretty much for this POJO class or pointer class. So basically we are just considering these three scenarios where x equal to x not equal to x, y not equal to y, and in the last scenario x and y both are equal. In that case we are considering value. Okay, now let's come back to our main class. So what I will do, I will take one list variable there. So it should be list of integer. So basically what we will do, I am going to traverse using DFS. I am going to store all the nodes here, right? So it should be actually list of pointer, right? So pointer, let me name as points only. Okay, and it should be an array list. Okay, and generic types. Okay, now what I will do, I am going to call directly DFS here, right? So it should be, I will create one function DFS and I am going to pass my root node. Initially for root node x will be 0, y will be 0, right? So let's implement our DFS function. So it should be private and its return type should be void, and let me name it as DFS only. And what we are passing as parameter, we are passing tree node. So tree node, then again we are passing int x and we are passing int y. Okay, so when our DFS will stop, whenever I am going to reach in my leap node, so where my left or right value is null, then we are going to stop, right? So that will be our stopping condition. So if node equals to null, then we should not move further, right? We can stop return like this since return type is void only. Okay, so now what we will do, so we are going to insert in our points list, right? So it should be points dot add, and it should be a new pointer, whatever the POJO we have created, and we are passing three value, right? It should be x and y, and again we are passing the node dot value. Okay, node dot value, right? Whatever the value is. Now once we add this, I am going to recursively call the DFS to cover all the nodes, right? So we covered for the root node, then again I will move to the left side. So it should be node dot left. So node dot left. So whenever we are moving to the left side, we are doing x minus 1, right? So we are going to write the same logic here. So x minus 1 again, and y will be increased by 1, right? So y plus 1 again. Once we are done with the left side, we are going to do the same for the right side also. And DFS node dot right, and again whenever we are moving to the right, it should be plus 1, right? Because we are moving to this section, right? So it should be plus 1. Whenever we are moved to the left section, then we will do x minus 1, right? So that's the main difference, and y should remain same, y plus 1. Okay, so I think we are done with our DFS function. Now let's write our actual code. So what I will do, so at first I will sort the collection, right? So collection, so basically in the points we have all these nodes, right? Like this, we have all these node, but that's a pointer node, right? So we are going to call the inbuilt sort method, and we are going to sort these points list, right? But whenever we are applying the sort, it will by default it will use this compare to method, right? So it will sort using this logic only. Okay, so now it should look like points. Okay, now what I will do, I am going to declare my actual array, whatever we want to return. So let's declare that first. So it should be list of integer, and again let me define that as the result, and it should be a new array list. Okay, now what I will do, okay, let me define that. So what I will do for the 0th location, I am going to add one blank list, right? So initially it is blank, right? So I am going to add a new array list, and array list will contain integer, right? So it should be integer only. Okay, so for the 0 location, I have already initialized one list, right? Since its size is 0. Now what I will do, so basically what happened now, so what happened till now, let's see that. So basically we had this vertical, we had this collection points, right, and we sorted that, right. So now it's sorted according to our location, right, in the x location, right, x and y location, whatever. So basically it looked like, so let's consider this for example, right. So it look like this only, but it's a single list, right. We need to combine those according to our x index, right. So it's basically at first it was unsorted, then we sorted according to our logic, then but that's still a single list, right. This is a single list, right, but we need to combine those or categorize those according to our x value. So we will do that, right. So to do that we are just considering the x value, right. So what will happen now, so I am going to take one temporary variable called temp probably, okay. In the temp value we are going to store the initial value, right. So what will be the initial value? Points. So it's already sorted, right. So I know, so it should be points dot get 0 and it should be the x value, right. So since we are considering x, right, since we need to just consider the x value, right, so while categorizing those, right. So okay, so it should be point dot x. Now what I will do, we will run one for loop and it should we should call the pointer. So we will go through this sorted list, right. So pointer, let me name it as ps, and we will go through this points list. So whatever we sorted earlier in this here, so we will go through each and every element, and if I see that my x is similar, then we are going to create separate category, right. So if preview if temp not equal to ps dot x, that means it's a different category, we are going to write code for that. But if the value is same, then it's the same category, right, we are going to insert in that only. So it should be result dot get. So we are just we need to add in the last position, right. So initially it was 0, then we created one blank array, right. So it should be result. So we are going to store it on that particular location, right. So it should be result dot size -1, and we are going to add there, right. So initially it will contain the blank array list, and we are going to add the value there only, right. So it should be ps dot value, okay, whenever it's not matching, right. But if it's matching, then what we will do, we are going to create our new temp value. It should be ps dot x, and what will happen here now, we are going to initialize another new array list, right, for that particular location. So it should be results dot add. Again we are going to initialize one new array list, right, array list, okay. So now again it should be integer, and okay, it will look like this, and once we are done we can directly return result, right. So let's return result from here. So I think there were a couple of issues there. So at first there was no return type, I added this, and it should be minus only instead of equals. Let us run it once again and check, okay, whether it's giving us expected answer or not. Yeah, I think it's giving us expected answer. Let's submit it also and check that the time complexity and all. So let us open the same, and I think it's beating the 100% Java solution. And okay, so now let's go through our code and try to understand it, right. So what I will do, I will just copy the code here, and okay, just give me a second, I'm pasting it. Okay, so let's go through our code once again, right, and for better understanding. So what we done here, we created one separate Pojo class, and in that Pojo we are tracking 3 things, x, y, and value, right. So basically now what we are doing, we are just wrote our compare logic or sorting logic here. So if my x is not matching, then we are considering the smaller x, and if my x is matching but y is not matching, then we are considering the smaller y value, and if it's x and y both are matching, then we are considering the small value, right, the smaller value, okay. So that's our Pojo, we defined it. Now what we are doing here, we are just initialize one list. So okay, so let us take one list quickly, okay. So 157, it should be size 7. Let us take it quickly. Insert. Okay, so I took one 7 size list. Now what we are doing here, we are just running DFS, right. So we are running our DFS here, right. So we are calling DFS root 00, right. So in the DFS what we are doing, we are just checking it's not, if its root is not null, then we are just going to add it in our list, and we are going to do the same for left and right. So we are going to depth for left and right both, right? So basically what we are doing, so I will start from 1, I will insert 1 here. Again for 1 we are going to store 3 things, right? So let us define it here quickly. So we are going to store 3 things. What are those 3 things? Initially we are storing the x value, so x value is 0. We are storing y value, that is also 0, and we are storing the actual value, right? So this is 1. So this way we are storing for everything, every nodes, right? Again for 2 we are storing three things, right? So our x value will be, since we are going to the left side, so it should be -1, y value will be 1, and actual value will be 2. Now suppose I go to 4, again for 4 we are storing like this, right? So for 4 it will be look like this, right? So it should be, again for 4 it should be -2, y should be 2, and actual value should be 4. Again after that probably we will visit 5, right? So we will visit 5, and for 5 again what will be the value? We are moving to the right side, right? So it should be 0, right? So 0, and y should be 2, and actual value should be 5, right? Now after that probably we will come to 3 here, and for 3 how it will look like? It will look like it should be +1, y should be +1, and actual value should be 3, right? Again we will come to the left, and we are going to store 6 here. So how it will look for 6? For 6 again it will go to the left side, 0, y should be 2, and actual value should be 6, right? Now again at last we are considering the 7, and for 7 how it will look like? It will look like it should be 2, y should be 2, and actual value should be 7, right? So after doing the DFS it will look something like this, right? And each and every node have 3 values, x value, y value, and the actual value, right? So now what we are doing here, once we are done with our DFS, we are just doing this sort, right? So after performing the sort, how it will look like? So let us take quickly another array, and let me insert 2 more column there quickly. So insert column, okay, just give me a second. Another one. Okay, so it will look like this. Now we are just doing the sorting using this logic, right? So using this comparator logic we are doing the sorting, okay? So what did it say? So whenever we will sort, we will consider this value, right? At first we will do the sorting for 0, 0, right? So what it will look after sorting? So it should be, we should consider 4 first. So 4 will come first, then again it will come to 2, since 2 has -1 value for x, then again it will look like 1, again it will look like 5, again it will look like 7, okay? So it will 6, again after that it will come to 3, and it will come to 7 at last, right? So this will look like 4, then 2, then 1, 5, 6, then 3, 7. But so it will be output after sorting, right? After this line it will look like this, okay? So after this sorting it will look like this only. So now our challenge is to do the create the separate list for same index, right? So since it's a single list, right? So we need to separate those, right, according to our x index. So for that logic, what we are doing, so we took one temporary value, right? So we take another actual list, and we take one temporary value, and temporary value should be it should be the initially our value is its initial value, right? So initially we have 4. So for 4 we have x value. What was the x value for 4? For x value was -2, right? So I am going to store that as -2. Now what I will do, I am running the for loop, and I am going through each and every pointer, right? So now we will pick the first one, 4, and for 4 I can see, okay, 4 had already -2, right? Okay, so I found that, okay, for 4 I have already same x index, so we are not going to create any new list. So we are going to insert 4 in the existing list, like, so it will look like this 4. Now what I will do, I will come to 2. For 2 I have index -1, right? So that's not matching, right? So that means it will be in separate category. So my temp will become -1, and I am going to initialize another new array, right? So I am going to initialize another new array, okay? So and again, or new list rather, I am going to insert 2 there, okay? Now again I will come to 1, and for 1 again I have separate x value, right? For 1 we have value 0, right? So my temp will become 0. Again, I am going to, so since that means my x value is changing, means we are just going to create another separate list, right? So I will going to add 1 there. Now I will come to 5. For 5, I can see my x value is same, right? So for that, we don't need to create separate list. We are just going to append it in the previous list. Similarly for 7 also, right? Now again, it will come to, similarly for 6 also, right? Now again, it will come to 3, right? For 3, we have different, right? For 3, x is 1, right? So that means that will be separate list, and we are going to initialize that. After that, for 7 also, x value is 7, it's different, right? We are going to create a separate list for the same, okay? So we are just doing this thing only here, right? So basically, we created one, we initialize one list, and we are just appending in that list using this result.size -1, right? So basically, we pick that particular location and we are appending there only, okay? Okay, so what will be that our time complexity? So basically, what time complexity will be order of nlogn. Since we are doing DFS and we are going to the for again and again, we are iterating through the loop, and for the time space complexity, we are not using that much of extra space, so it's a linear space, so it should be on order of n, right? So if you like this video, please subscribe to our channel. I am going to add the code link in the video description also. And thanks for watching. Bye bye.